All right, this will allow us to post multiple separate sections.
Right.
So welcome to the Mastery Grading in Action session. We are recording this and we will be posting this in our YouTube playlist, and we'll be letting you know where to find that. And so we will be rebroadcasting it, and that includes the chat and the Q&A. So please keep that in mind, and please keep the questions coming in the Q&A, especially if it's something you'd like one of our panelists to answer live. All right. Thank you to College Bridge, as always, who is our sponsor and who makes this possible. And with that, I'd like to go to the next slide and introduce, I'm sorry, I'm working here with someone else changing my slides. So we are in this session where we'll be describing concrete examples of how our various classes work, and that will answer a lot of the questions you've had. There is a progressing section going on right now. If you're interested in if you have used Mastery Grading before, you may want to go over to that one to discuss what you have done before. And following this, there will be a coffee break, and then our keynote speaker for the day, Linda Nilsson, who is the creator of one of the types of Mastery Grading you will see us introduce in this session. All right, next, please. So we're going to start with Sharona Krinsky, our host here, who is going to give her example of using standards-based grading in an introductory stats class. Sharona?
Sure, absolutely. Thank you. So for those of you who haven't seen me present before, I'm Sharona Krinsky. I work at California State University, Los Angeles. We are a relatively large four-year public teaching university, about 23,000 undergraduates. We are a Hispanic serving institution. And as I have said previously, a couple of years ago, Cal State University, which is a 23 campus system of about 500,000 students, did away with remediation in math. Every single entering freshman is placed directly into either a general education math class or a pre-calculus class. The first semester they hit campus, and I'm one of the coordinators of our Math 1090, which is quantitative reasoning with statistics. It's sort of an intro stats class, but not a traditional one. We typically have 1,500 to 2,000 students in the fall in this course, in sections of size 25 students each. So we've got between 50 and 80 sections, which means I'm working with anywhere from 20 to 25 instructors. And we meet 3 hours a week. And we use active learning. We use iClickers and inquiry throughout the course. And it is standards-based graded. So we have 15 total standards in the course. And in order to get an A, you have to master at least 14 of them. And then an A- is 13, a B+ is 12, 11, 10, 9, and we're no credit. So it's ABC, no credit, 8 or fewer. And I'll be going into how you master these. We use primarily quizzes and re-quizzes. We have some portfolio style homework. And this is version 4 of our standards-based grading. So we have iterated this over the last 2 years. Yes, this is definitely just one style. This is my style. I actually also teach in Drew's team-based learning inquiry, linear algebra, and it's a different flavor. So even myself as an instructor uses 2 different flavors of mastery grading. So like I said, we have 15 standards in our course. And of those 15 standards, 11 of them are what I would call content standards. They are about statistics. 10 of them are your basic statistics studies, statistics standards. And one of them is a standard we have on critiquing the media. So the goal of our course is to create a critical consumer of data. So we want every single citizen in this country and every single resident to be able to critically consume the data that is shown to them. We also have 3 what we call mathematical practice standards. So these are standards that are not specific to statistics, but they're things like using mathematical and statistical tools with precision and accuracy, creating a convincing, viable argument based on justification, mathematical justification, and using quantitative reasoning in context. So those are our 3 mathematical practice standards. I also have 1 habits of mind standard. So this standard, which for ease and convenience and logistics is a points accumulation standard. We have this massive pile of points available, usually about 1,000, and students choose how to pile up 700 of them. So this is by either showing up to class. There's a partial flip on this. So if they read the book ahead of time, they get some points. If they do some video watching, they get some points. If they do some homework, they get some points. there's just a variety. If they participate in class, they get some points. This idea for us is that these skills, preparation, participation, and practice, are actually something we want them to master. So we call it a standard, and it kind of, again, grading wise, it's points accumulation, but it's not partial, it's almost all auto graded. So there's where your automatic grading systems and homework systems can come into play. So we do have, so that's our clear list of learning objectives. We do assess for mastery. We use a 4-level rubric. Because again, I'm working with 25 instructors. So we're trying to get people on board. Some instructors have the need for more levels of feedback. So we do use a higher level. Our top 2 levels are both mastery. They're equivalent, but some instructors feel like they really want to give that extra feedback of, wow, you really went above and beyond. So we have a check and a check plus. I do like using emojis instead of words now, because I kept fussing with words, meets mastery, meets expectations, proficiency, whatever. I just went to emojis. Thank you, Stephen Klontz. And then I have 2 levels that are not mastered. The black cloud is you're still got to think about it some more. And the red X is you didn't give enough information. I can't even tell where you're at. So it's either you didn't turn it in or you left it mostly blank. At the moment, this might be changing. So anyways, you have to get mastery twice on most of our standards in order to have actually mastered the standard itself. So you need a check or a check plus twice. Our initial attempt is a homework style portfolio. It's untimed. Students are allowed to work with other students. We do turn it in so that we're checking for plagiarism. But other than that, they get as much time as they want. They're allowed to get help. So that's their first opportunity. The second opportunity is a quiz. So that's a timed assessment on Canvas. And then we have 2 requizzes. You don't have to do one on the portfolio or the quiz. We don't care where you get your checks and check pluses, which is confusing for students as well. And then the final exam is the ultimate requizzes. So we give 5 chances to achieve a check or a check plus twice. And that's except for that P-cubed standard, which is points accumulation, and any of the standards are equivalent. So you can get an A and do nothing on the P-cubed because you only need 14 out of the 15 standards. Or if you're someone who typically would get a C, this is an extra way to get up to a B minus. So those standards, every single standard is both completely unimportant because you can get any grade without it, and completely important because it raises your grade by a full 1/3 of a letter grade. So that's sort of my course in a nutshell. Is there anything in particular I should look at? Oh, I will answer this one. What's the purpose of having 2 different mastery levels? In my system, it's just to allow the fact that we have such a wide variety of faculty and their needs for feedback. When I'm not doing it in a coordinated class, I only have 1 level. But we have found with other faculty that sometimes if you don't give a level above mastery, then they require perfection for mastery. And since I don't want perfection for mastery, I have to give a step up. Right now, for the last year, all of our assessments were online in Canvas. We used to do it in class for all the quizzes. What we're looking at doing now is keeping at least the requizzes asynchronous offline. We're still debating whether the initial quizzes are timed in class or they're able to be done asynchronously. There's equity issues in all options. So we think we want to give as many options as possible. So we're looking at that.
I just wanted to call your attention to a follow-up question in the chat from Chelsea about if perfection is not required for mastery, then what is the level, right? How do you describe what mastery means?
So it's very interesting. It's one of those, you know it when you see it kind of things. And what we do, again, because we have 25 instructors, is we actually get together as a big group and we grade a few assignments together and we agree on what mastery looks like. So, especially in statistics, our standards are things like, I can evaluate a statistical study. That might be the standard. So we have to come to agreement on the particular problem as an instructor group. What does mastery look like? And so if it's a 5 or 6 part problem where we're asking them to identify 5 or 6 things, it might be that maybe 4 out of the 5 they really have to get right, but they can miss one piece of identification, something like that. All of the statistics instructors in my course, so all 25, are required to do this. This is a lockdown type coordinated program. So all of the instructors, and I'll be talking about this more in a panel tomorrow, are required to do it this way. Okay, I think we should let Drew go, and then I will come back and answer those questions at the end.
Yeah, and I think kind of pointing out some of the differences we have among our things will answer some of these questions, which have a flavor of, do we have to do this, or which of these things are really necessary? So Sharona mentioned I'm going to talk about the linear algebra course that I have been teaching a lot of the last few years. So for me, this is a sophomore level service course. 80% of my students are engineers. And I'll typically have 20 to 30 students per section here. Pedagogically, what I'm doing in the classroom is what I call team-based inquiry learning. And so the assessments are set up through standards-based grading. So typically, kind of the assessments I'll give the students every week will have either a quiz or an exam. The quiz will have basically the 4 most recent standards, and then an exam would have all the standards we've talked about so far. And then so I'll scatter 4 exams through the semester, and every other week we'll have a quiz on the most recent things. So the objectives for the class, I want to mention here that I've really closely aligned how they appear through everything in the course. So they're very closely aligned with the class activities, the homework problems, and then the assessment problems. So we have an activity book that my colleague Stephen Klontz and I wrote for this course. And you see the very first thing after the front matter is the learning outcomes, right? That we up front say to students, these are the exact things we want to learn. And maybe that's a little bit small, but for example, E3 there says I can compute the solution set for a system of linear equations or a vector equation. And on the next slide, I've got my an example of a homework question here. So I'm using Stephen Klontz's check-it system, which he'll actually talk a little bit more about in a session tomorrow, if this sounds interesting. And so you see on the homework problem, I have the standard repeated up there, right? So not just the little code, but the whole outcome that I want them to do. And then we have a problem that is exactly aligned to this exact outcome that I want them to have. And Stephen's website is nice. See those numbers up there, 1, 2, 3, 4, 5, are just a bunch of different problems. I think he's got it set to go up to 20 or something as well. And then up in the upper right corner, it's hard to read, but there's something that says show instructor features. And if you click on that, you can then produce assessment problems that are in this exact same format and tied to this outcome. So on the next slide, I've got an example of what that looks like. So you can actually use this software to produce question banks in Canvas, where each student gets an individualized problem in Canvas tied to this learning outcome. So when I assess these, this is exactly what it looks like in Canvas. It's very similar to kind of what Sharona is doing, but I have kind of focused this more on, instead of describing their work, more on what do they need to do next. So kind of what I'm looking for is I want them to demonstrate excellence. Okay, so I took the word mastery completely out of the vocabulary that I use with my students. I don't use that at all with my students. So if they do everything I want them to do, then I mark it as demonstrated excellence. And then I have 2 options for, okay, well, I didn't demonstrate excellence, what next? Sometimes they just need a minor revision. So a lot of times what this looks like for me in a math class is they have maybe a notation error, right? So one of the things I do want them to work on is their writing and communication, but that's not directly tied to the standard. Or maybe early in the problem, they will write 2 + 2 = 5, and then it throws off their calculation for the rest of the problem. Well, 2 + 2 is not equal to 5, but that's not really what I'm testing when I'm looking at linear combinations, right? I really want to know, can they tell me if a vector is a linear combination of other vectors or not? I really don't care if they know what 2 + 2 is. So I can use that minor revision to tell them, hey, look, you wrote 2 + 2 is 5, go back, fix this, revise your work, and then give it back to me. And then I can bump you up to demonstrated excellence. And then if they haven't shown everything I want them to show, then I tell them, okay, I want you to work a new problem next time. So that's what that last category is for. So I emphasize to them that their eventual mastery matters. Okay, so similar to Sharona, I want them to do these things twice over the course of the semester. This gets back to some of the questions we had before about, okay, well, yes, they learned it, but how do you try and measure that they retained it? So one thing I like about asking them to do it twice, so one, either they learned it and retained it to show it to me a second time, or they learned it, forgot it, and relearned it, which actually probably more accurately reflects what's going to happen when they leave my class, forget most of this stuff, and go off to their engineering class when they then have to relearn this stuff. So if they've shown me that they can learn it, forget it, and relearn it, that's actually pretty good. I'm pretty happy with that. And then I want to mention that I offer them on-demand reassessments in addition to those quizzes and exams. So in the before times, what this looked like is they would come to my office hours and they would knock on my door and they would say, Dr. Lewis, I want to show you I can do linear combinations now. And I would say, great, there's a chalkboard, here's some vectors, tell me if this other one's a linear combination or not. More recently, I've been using Canvas for this stuff. So I can set up a problem in Canvas and give it to them to work on. And I want to mention that you can use the flexibility of this kind of thing to have these kind of formal reassessments, but also informal reassessments. Usually at least once a semester, I'll have a student, I guess not virtually so much anymore, but in the before times, they would get back an assessment, and multiple times I have a student just burst into my office and just say, Dr. Lewis, I know how to do this. You see that this is what I did wrong here, but it should have been this, and then that changes this, and then it fixes this. And by the time they're done, they have completely and thoroughly explained to me everything I would want them to learn about this particular topic. So in that case, I can just go into the gradebook and say, oh, well, great, I'm happy. You showed me in this way, right? Not in the formal way, but in this other way, how you learn this material. A couple miscellaneous notes. I want to point out that maybe not everything you ask students to do has to be included in the grade. So for instance, I no longer include homework in the grade. They need to do homework for practice. I ask them to do some homework problems before they do a reassessment with me or an on-demand reassessment with me. I no longer include attendance in the grade at all. Actually, the first semester I stopped doing it, I still tracked the attendance, and the attendance was basically the same as in the semester before when it counted into their grade. And then same thing for things like self-assessments or weekly discussion posts. I used to count those kinds of things in the grade somehow, but when I stopped doing it, they still completed them at basically the same rate. So therefore, I don't understand the point of doing that for my students anymore. And the last thing I want to say is to echo Sharona's point that I've been tweaking this over several years, right? So every semester I change something different. I'm going to look at the chat now and try and I think that there's a few questions in there I will answer, but I'll go ahead and hand it over to Gloria to talk about her physics class.
Hi, everyone. So for those of you who don't know me, I'm Gloria Ramos, and I teach physics at Citrus College, which is a 2-year college, community college in Southern California. And I'm going to talk about my Physics 202 class, which is a physics with calculus class for STEM majors. In the before times, that was a flipped class. And my typical assessments are preparation assignments where students watch videos that have questions, or there's a separate preparation assignment. There's a set of skill builder assignments that are formative that students can resubmit. And those skill builder assignments vary from kind of traditional practice problems, specific assignments I give them. And now in the pandemic times, that also included sort of online lab type of things. And my tweak for this semester, because much like Drew and Sharon, I think all of us who do this, I'm changing something every semester. So I decided to get rid of exams in this class and have students put together a portfolio. And if they wanted to get an A or B in the class, then they had to do what I called a portfolio interview. In the before times, when I would give paper exams, I would have students come to my office to do they were required to come to my office to look at their exams and do that sort of in-person reassessment type of stuff that Drew mentioned. So for the portfolios, I decided to do this portfolio interview, which is a one-on-one face-to-face appointment the students have with me, where we talk about not just their portfolio, but in their portfolio, and I'll talk about that in more detail in a second, I may ask them some additional questions. So it's not quite as extreme as an oral exam, but it falls into that general category, I would say. And in my course, I basically have two types of outcomes. Some are content outcomes, the majority are content outcomes. Some are very broad, such as I can predict, analyze, or explain the effect of an electric field on a charged particle. And some are very specific, and that's usually a particular skill. So that could be, I can calculate the electric potential for a system of point charges, right? So that's a very specific thing that they should be able to do. And then I have some scientific best practices outcomes, and some of those are about scientific argumentation. Some, when we were on campus, they were things like good lab practice, being good team members, critical showing kind of good communication skills and critical thinking, and other kind of good scientist type of things. Next slide, please. So here, I wanted just to focus on one specific outcome so you can kind of see how this develops for me. I have this is one of my broad outcomes. It's one of the first things we do in this class, and I give the outcome as well as the related skills to the students. And these related skills, they are also tied to the assessments that I give the students. So I will ask them to do all of these different skills in the various kind of formative skill builder assignments. And then they use those skill builder assignments to build their portfolio. So the skills build the assignments, and then their responses to those assignments serve to build the student portfolio. Next slide, please. So some of the assessments, here are some of the questions, for example. So again, in the before times, they would have done the tape experiment themselves, and maybe even the balloon one, but this time we did it online, where they watched the video and then answered questions about it. And then these questions are graded based on my rubric. And if we can have the next slide, please. I think that has the rubric. So this is a claim evidence reasoning rubric. I still use MRN because I link mastery to Jedi Master in my class. I have a whole kind of Star Wars thing going on with my rubric. So when they're answering questions, for example, about that particular lab, this is what I have in my mind in terms of when I'm grading it. I use this rubric to determine where they're at. So students are usually pretty good at claim, which is their answer, and maybe evidence, but the reasoning is very often not there. So I explicitly make my students identify, hey, where's your claim, where's your evidence, where's your reasoning? and being able to use claim evidence reasoning for their scientific argumentation, that is one of my standards, and that one is assessed pretty much every time they have to explain something. The content standards are, they have to show mastery twice. So once is basically by completing the skill builder assignments, and the other time is through their portfolio. And the portfolio, which is the next slide. So here's an example of one of my students did for their portfolio. So they know in their portfolio that they have to address the outcomes. So their portfolio is done through something called VoiceThread. And if you're not familiar with VoiceThread, it's a really great tool where students can upload pictures or slides and even videos, and then they comment on those pictures and videos. So this is the picture that this particular student uploaded, and then along with this was audio commentary. So the portfolio is the students in their own words describing the outcomes and the physics to me. And if they did a problem, they might have a homework problem that they did, and they go through it and kind of explain how they understand, as an example, calculating the electric potential of something. And then I did all the interviews through Microsoft Teams, which was really, really great. It was easy to schedule that. And again, if there was in their portfolio, if I felt they didn't quite show mastery, I could ask follow-up questions during the interview. And in addition to that, I could also give them brand new questions that they hadn't seen before. It was always kind of phrased in the context of, hey, we're having a conversation, tell me what you know about this. So it wasn't so much about calculating a number or doing a specific integral or whatever. It's about how would you set this up? It's kind of focusing on the physics of the situation. So yeah, there we go. I'll pass it on.
I did want to pop in quick and say there's a question specifically for you, Gloria, from Dan. Do you have your students write lab reports? And if so, how does that factor in?
I don't do lab reports in Physics 202, but we do that in Physics 203. And I have lab report standards. They actually not just do lab reports, but they also do like a research poster for a kind of an end of semester project. And I bill, the way I have my course set up, they don't write lab reports every week. I sort of teach them to write a lab report. So we'll do one experiment and then they'll only focus on like the method section of that lab report. Then, the next time that we do an experiment as opposed to an activity, we add more parts to the lab report so that over several weeks, they've mastered the skill of writing each portion of a lab report.
All right, so I am going to give the last example here. This gets into a little bit more of what would be called specifications grading. And you're going to hear more about that from our next keynote speaker, Linda Nilsson, this afternoon. But the class I'm talking about is called Math 210, Communicating in Math. And while this is a very math-specific thing, it's going to have some features that apply really broadly. So this is our bridge into higher math. It's where we move from sort of a more formula, one right answer focused type of thing into a, how do I communicate my understanding thoroughly, especially in a case where there's more than one way to do this. And so there is a point like this in any major, right? There's a point where we want our students to move into a broader view of things and communicate things in writing or verbally in some other ways. And that this course for us happens as early as we can make it, often in students' freshman year, maybe sophomore. So this is a writing intensive course. It satisfies Grand Valley State University's discipline-based writing requirement. It tends to be kind of worldview challenging too, meaning this idea of, oh, there was always one right answer before, and suddenly we're asking students to create their own approaches to entire problems, which may have multiple correct approaches. The small classes, about 20 students, 4 hours a week. It's flipped. There's an inquiry-based aspect. I am happy to talk about all of these, but I'm not going to focus on it here. What I want to focus on is how this assessment approach works when we want to focus on holistic assessment, and something I've seen a lot of in the Q&A. How do I avoid siloing ideas and separating them out into little pieces and ensuring that students can synthesize and put together big picture things instead? So 2 basic types of assessments. The first are using in-class weekly quizzes. This is where I test very direct, more or less computational things. And the second, the one I'm going to spend my time on, is the proof portfolio. This is the big final assignment that we happen to do throughout the semester and is due as a whole at the end of the semester, where students produce 10 written proofs, and the focus is on communication, logic, and synthesis. So if you take a look at this very colorful grid that I have up here, many of us have something similar in our syllabus. This is where final overall letter grades come from. You can see that there's 2 things students need to do for any given letter grade. They need to professionally communicate a certain number of proofs, or in other words, produce a certain number of professionally communicated artifacts. And they need to complete some learning targets. That's the language I use, complete the targets, which means they can demonstrate the specific skills used within those proofs that they are writing. And so at different levels, they have to complete different numbers of these successfully. All right, next, please. So this is just for those of you who haven't seen it, this is an example of what a mathematical proof might look like. You can see that there's some formulas in it. There's a lot of writing involved. Formulas are incorporated into writing. There's explanation that's done verbally. There's a certain format to it. This is learning how the people in the discipline communicate with each other. That's the goal of this class. And so this is the type of thing that would show up in a portfolio. I'm not going to go through it in great detail, but just so you've seen, this is the type of thing they're producing. Okay. So in my class, there's 2 types of objectives that come into play. The first are what I call learning targets. These are skills, right? They are more computational or more direct, little atomic-based things. So an example here on the right, this numbers target, and one closure. Closure is a topic we learn about in class. And I have a list of things after it that a student who has completed this target should be able to do. I want you to notice the 2 check boxes next to it, also with slightly different colors. One of them, the yellow one, means the student needs to demonstrate that they can do this on a quiz or exam, an in-class assessment where it's a very direct thing. No writing, I'm asking them direct questions, right? This is the identify if a set of numbers is closed or not and tell me why. The green one, they need to also do this on one of these written portfolios where they synthesize and put these things together into a more complicated, bigger picture piece of writing. In order to earn credit for this objective, they have to do both of those. And that's a common thing I encourage people to think about. Require demonstrating their understanding both in and out of class, or in a sort of skill-based and in a synthesis organized way. The other kind of objectives are specifications. These are for writing and for synthesis. And a specification, again, we're going to hear more about this from Linda Nilsson this afternoon. Specifications are a list that describes what a successful portfolio proof looks like, right? This is both formatting and also content. This is writing style as well as mathematical meaning and logic. And I have just an example of a few of these here. We actually developed these specifications together in class, and our book supports this. And the very first one, I think, is one of the most important. A professionally communicated proof must be correct, right? It must be mathematically correct. And I justify this as, if you've learned to do a beautiful presentation of something that's very convincing and it's wrong, you are learning a dangerous skill, right? And that's not something that we want people to learn to do. And this is also, then I should say after that, there's some other requirements. We need to type these things. They need to include a certain sort of explanation. And there are many other things. I'm just including a snippet of them here. A proof is assessed holistically on these, not each of these specifications separately, but as one overall thing. Did the student consistently demonstrate that they can do all of the things in this specifications document or not? Just an overall, yes, consistently did them all, or no, you did not. All right, so let's take a look then at how this actually works. So next, please. All right, so when students are assessed for mastery, I'm going to focus again on the portfolio problems. This is how that works. So students can actually put learning targets of their choice on a proof on a portfolio that they've written. And those are assessed based on a 3-level rubric. It meets expectations, that's the language I use, or they're progressing or not yet. Only meets expectations matters, the rest is just a matter of a little bit of extra feedback. Students can propose these, and that's a very high level thing, right? The level of metacognition to understand what is it I did in here and which learning targets are relevant is a big deal. And it's something we work on a lot in the class. That's quite intimidating to students initially. But then it's also assessed all or nothing using these specifications for communication. So again, that's one overall, yes, this is professionally communicated based on all of these specifications or not. Here's a key thing having to do with synthesis. Students can only earn credit for the learning targets in the proof if the proof meets all of the specifications for communication. That includes being fully correct and well communicated. This is what encourages students to view the proof not as a bunch of separate little pieces, but as one big interconnected whole that they need to fully understand in order to earn credit for each part of it. So here's an example of how this works in terms of multiple opportunities to demonstrate mastery and eventual mastery mattering. So there are 10 portfolio problems. I assign them. I don't ask students to assemble their own portfolio. I assign the problems that will go into it. And let's say we just finished a topic in week 5, and I might assign a portfolio proof and say, okay, go work on this now. A week later, I ask them for a rough draft. And this is very much in the style of Mandy Jansen, if any of you have heard of her rough draft math. This is, give me an idea, right? Don't worry about the terminology. Don't worry about the language. Don't worry about those communication specifications. We're going to get this down and see, your sort of basic level understanding here. And I give them lots of feedback. A week after that, they try to go for a polished final result, right? Bring in some communication, write it up really nicely, make it clear. And so these are each required parts, right? You must do a rough draft. You got to show me a rough bit of work, and not something you're trying to be perfect at. But then you're also going to try to attempt a final revision. All the weeks after that, I am freely available to talk with them about these proofs. And I've given them tons of support, feedback, questions, and so on along the way, but never any actual grades up until that point. Only at the final exam do they actually hand in their portfolio. And that's the only time I actually grade these. But of course, by that point, the feedback I've given has given them a really good idea of what they're solid on and what they aren't. Okay, so that's how the multiple opportunities thing comes out. It's really a long series of drafts, revisions, and a lot of feedback to support it. All right, next one, please. Couple little bits of detail. I'm not throwing students into this writing thing blind. We spend a lot of time reading, writing, and assessing proofs, both ones that I give them and each other's in class. And that includes developing these specifications, identifying learning targets. We practice everything they're going to do together in class with lots of support. And there's been lots of ways that I have failed at doing this. As you've heard many times now, right? This is the 4th or 5th revision. I started simple and some things worked and some didn't, and have improved a lot since then. One example of a thing that did not work well was having multiple separate objectives that covered different types of communication. I brought those all together into this one big specifications list that needs to be done in whole. And that's because they all matter. You really can't slice these up separately. We need students to think about the whole thing all together. And that's what the specifications have done for me. And also why fitting all of these specifications in is essential to earning credit for the learning targets. If you can't see the big picture, you probably should not earn credit for the smaller pieces separately. All right, those are the big things that I wanted to talk about for this. We can go past these to questions for the moment. And so I think at this point, we're going to go into some of the questions that have come up. Okay. So let's see.
There were 2 particular ones for you down at the bottom, David, from Anonymous and Lindsay.
Okay, let's see. So how do I determine the number of learning targets or the number of proofs students need to complete to receive an A, B, C, or D? So I start out, this is a common feature. I encourage you to start out by thinking about what would be required to be sort of the bare minimum to pass the class. What's the essential thing that a student earning a C would have to do, right? And so what I do is I identify the targets and roughly the level, the number of these that I think matches with my conception of what C means in this class. So not great, not wonderful, but the minimum to earn a passing grade. And then I adjust, right? Then what does A mean? A means a student has really excelled. And one thing I've noticed is that when I set a standard and I think it's kind of, oh, that's a little high, are students going to reach that for an A? They do. They amaze me by how far they can get. And the same for other standard levels that I set. But then I adjust those, right? There's always a lot of tweaking throughout things. I've lost where the second question was.
Lindsay, Nicole.
Okay.
I can read it to you. I'd love to hear more about how you work on the metacognition components in the class.
Yep.
What kinds of activities help students understand how to identify relevant learning targets?
Yep, absolutely. So there's a very large amount. The process might look like this. We usually have base groups of students who are always working together. I often assign those based on their availability. And in class, we might have them first construct a proof and then go read someone else's proof and then get out this list of learning targets that they have a list that they always have with them that they can compare it to, and try to identify what someone else used in their proof. So they're not as invested when it's not their proof, right? It's not as personal. And so we go through, everybody always sees different targets. And so we do a gallery walk around the room and say, oh, look at this one used this target instead. And people are like, oh, I see, that's something I should think about for myself. The more experience they have in sort of the low stress in class ungraded time, the more they're willing to do that on their own higher stakes portfolios.
So we're getting a lot of, before you continue, Dave, we're getting a lot of very detailed questions, and we're also getting the, oh my gosh, this is so overwhelming stuff in the chat. So I wanted to maybe take a moment and go back to something we said at the top of this thing. And these were said in this order for this reason. If you want to get started, these 3 pillars in this order are critical to think about. At least I personally think so. You start with, what do they need to know? You then go, once you know what they need to know, you start thinking about, how are you going to know if they know it? And once you figure out, okay, now they've shown that you know it, how are you going to give them chances to show it? So I think just to kind of bring it a little bit back in, because we tried to show you that every single one of us does it differently. There's no wrong answers. And this fundamental principle of grades should reflect demonstrated mastery of course content. You guys are in a course called Learn How to Do Mastery Grading. And this is our first checkpoint. So it's okay to be like, I'm going to throw something at the wall. The reality is, screwing this up completely is probably still better than traditional grading, in my opinion. So I kind of wanted to just close in a little bit on that, because I kind of felt like we were getting a little bit overwhelming here. But I do want to then go back to the Q&A and say, okay, so Dave, if you want to continue, I was feeling the vibe here.
Yes, absolutely. And we're trying to give you a wide variety of views on what can happen. And one thing I think I want to emphasize is, if you value it, you can include it in your system, right? As objectives, as specifications. And so if you're asking something along the lines of, but don't you do this? How do you do that? Absolutely, you can choose to include something. We're not prescribing one and only one way to do things, but being able to see a wide variety helps a lot.
We also have a great session tomorrow morning for people who are new called Build a Syllabus. And those folks wrote a paper that literally walks you through this process step by step. So
I think there was one other main thing I wanted to make sure to answer from earlier, which was a couple related questions of, we have a problem that our courses get siloed and students don't see the connections and synthesis. That's something I did talk about, but also a question of, if I'm putting a standard on a piece of work and saying, here's a standard you're assessing, doesn't that give away what I'm asking? Like if I'm asking them to perhaps pick a method to do something. And this gets at what I said about, if you value it, you can make it assessed. You can have an objective or a standard, which is, I can choose a method to do blank, right? I can choose a rule to calculate a derivative. I can choose a method for factoring a quadratic. And then if a student successfully does it, perhaps you could also give them credit for the relevant, I did it this way standard. But I think of these as either synthesis standards or approach standards, right? Can you choose an appropriate way to do it?
I have one that I wanted to talk about. Ann Moskal asked a while back, how does the grade distribution look like? And that is a very interesting question that I think many of us have had the same experience. I end up with a bimodal. I get A's, B's, and F's. I get an occasional C, but because the way my system is designed, once you get the C, it's just a little bit more work to get the B, and then it's a little bit more work to get the A. And what I find is that if you look at a typical C student, going back to that parachute packing problem, a typical C student is usually one of three. It's someone who fails early, damages their grade, works really hard to bring it up. It's someone who does well at the beginning and falls off, or it's someone who kind of putters around the middle and really gets nothing. So in the first case, someone who starts poorly and builds up, they're not going to get a C, they're going to get a B or an A. Someone who starts strong and fails off, or someone who never really gets anything, they're not really C students because they really don't know a large chunk of the class, and they end up down in the F range. Does anyone else want to add to that one?
I do want to confirm that I see a similarly bimodal approach, and I'd be happy to talk more about that. But yeah, more tend to reach the A range, fewer tend to drop.
And
same with me. Yeah.
Okay. Couple other quick questions. Sean asked, any reason you wouldn't want to make like my habits of mind standard of a higher weight? You absolutely can do that. Again, like Dave said, if it matters, that's where you put it. And you have to decide for your course what is more important. In when they get out of your course with a B, what does that mean? So it all goes in there. Anne asked, do I have a final exam for everyone? I make the final exam available to everyone, but I don't give a summary final. Like mine's the last reassessment and students choose. I think some other people have some other things.
I'd like to pop in because I see a question that I think many have been asking in various ways right down here, Jeff. Are there some standards that you have that are so absolutely mandatory you would not feel comfortable passing a student who doesn't master this one thing? And if so, how do you incorporate this? Yes, absolutely. A common way to do this. So again, if you value it, you can include it. So if you say this one thing must be done, then your grading system should say, in order to earn a C or above, you must do this thing. Many people assess that in a way by, for example, having a required part of a final exam where students must demonstrate their understanding of some small category of core learning targets. To sort of, Robert Calvert calls this recertify, that they still understand this. And then the remainder of the final might be further opportunities to earn credit for other learning targets or objectives. So that is one way to ensure students have completed specific things.
Drew, did you have any of these that you wanted to look at?
Well, there are two related questions that seem to come down to this kind of tricky question about midterm grades, right? And communicating students' progress in the middle of the semester. So I see one question from Eva that they're required to have a grade to date representing some proportion of their mark. And I think we've had kind of lively discussions about this in the Slack channel, right? I know different people do things differently, so I don't want to say that here is how to do it. I guess what I want to say is that one thing maybe not to do is to just take the number of standards they've mastered over time and divide that by the total number, because student progress is not linear. In particular, I've been teaching the same linear algebra course for a number of years, so I accumulated a whole bunch of data. And you can graph these curves of how students master these different standards over time. And the A students behave pretty linearly, but the students who end up with a B, it's a little bit more concave. And then the C students even more so. So if you're just trying to do like a linear extrapolation, that's not going to be a very good actually estimate of where they're going to end up at the end of the semester. So I usually do something a little bit more kind of holistic around trying to satisfy those university requirements. I only have to do it once. At one point, they asked for a midterm grade, and I give kind of my holistic best judgment. If you keep doing what you're doing, my experience says this is where you'll probably end up. and then I communicate to the students that that's what that means to them.
There is another collection of related questions about reassessments. And by the way, for all of you thinking about reassessments, we have a panel on reassessments tomorrow that I encourage you to come to. But there's one particular aspect that I think is really important here, asking sort of about workload on students, amount of time, lengths of assessments, and so on. And what I want to say about that is when you're including opportunities to reassess, to try a new problem, to revise, or whatever it may be, you need to think of that as part of the workload of the class and adjust the other things that you've included appropriately. So you're not adding additional work to the students. You may need to remove something else that you have previously included to account for the time that students will take when reassessing or revising. That is very important because otherwise we are overloading students. This requires you to think really carefully what matters and what doesn't. But other questions about reassessments, I think we can definitely answer in that panel tomorrow in detail.
The one thing I do want to touch on, Dave, about assessments, though, is this issue of academic honesty, because it's come up several times. I feel very strongly that it is incumbent upon me to make it mildly difficult to represent someone else's work as your own. So particularly in some of my lower level classes, like the stats class, where I have 2,000 students taking essentially the same exam asynchronously over 48 hours, I have an obligation to do some versioning. A lot of what we do is they take it asynchronously. The individual assessments are timed, but I break them up. So I'm getting to the point where I'm literally giving one question per assessment, and I'm giving it for about half an hour. So it could be something that should take them 5 or 10 minutes. They could have plenty of time, so we're not having that time pressure. But a 30-minute period is short enough that they can't do the really hideous thing, which for me is going to check getting someone in somewhere in overseas to answer it and submitting it back. It does happen. I do police that. That is the one thing I care about, is I really don't want you submitting someone else's work. So typically I do some at least mild versioning using the tools built into my assessment system so that I can catch the egregious ones. I'm not too concerned with them working together in the class, because even if they do, and I know that they do, the reality is in the work world, that's what we do. You know, really, I'm trying to get them to not completely represent someone else's work as their own. You can do that by, and this is another thing I do, I tell them that I reserve the right always to arrange a call with them for them to explain what they gave me. So if I have a student that their work seems awfully similar, or it seems like out of character for that particular student, they can, as part of the mastery assessment process, have to come meet me on my Zoom cafe hours, which is what I call my office hours, and talk to me about the problem. And I might get more insight into what they know or less insight. So there's definitely some, at least minimal effort, in my opinion, to do that. I don't do it to an extreme because I'm trying to mimic the reality of, and I'm trying to write my assessments in such a way that they're so aligned to my standards. They tend to be misaligned to material that's available, like on the internet. You know, I'm not assessing, honestly, if Photomath or Wolfram Alpha can do the problem better than the student can, then I'm not assessing the right thing. So that's how I do a lot of that. Anyone else want to weigh in on the academic honesty thing?
I'll add 2 things real quick. So to your point about the Photomath, I've in the last year or so shifted all of my prompts to be a whole lot more about explaining how to do these things. So if they just do the calculation, to me, that's not showing me anything, right? I'm looking for this explanation. So that helps a lot. And then the other thing that always comes to mind when people ask about the collaboration part, like, aren't you worried about your students collaborating? And I usually think for a moment, I'm like, well, they all have individual problems. And I have this vision of them all sitting in the room with their individual problems, all collaborating and working together and learn on this stuff. And I'm like, that sounds fantastic. Like, yes, go. If they do that, I'm happy, right? So.
Drew, you had commented, Lynn Lawson asked a question about feedback. Do you want to start that? And then I also can say something.
Yes, I do think we need to, that's a really important question that we maybe kind of jumped over as we were talking about kind of the mastery grading aspect of it. Absolutely, there's written feedback on there aside from just the rubric mark. So in particular, I gave the example from Canvas. Canvas has a great way to add comments in there. You can even add videos in there for video or audio feedback for students, which is great. Sometimes I think there is space to sometimes put a mark on there saying that there is a minor error here or something, and I want you to find it, because that's a valuable thing for students. And I know, I think, David, you've mentioned doing that kind of thing as well. So if you're clear about students that there is an error here and I want you to find it, then I think that is an okay thing. But for the most part, I'm putting a lot of feedback on there in addition to just the mark.
I don't know who I got the idea from, but I developed a mark for, there is a small thing, and if you can correctly explain what happened there, I am convinced that you've mastered this. And if you cannot, then I will be convinced you've got a major misunderstanding. And I created a little symbol for that, and students have to come and tell me about it, or they can just accept that they've got to do it again in a different way. That's fantastic, because usually it is something students can't explain, and it saves me from creating a new assessment.
It may have been Jay Elsinger that did that first.
That sounds about right, yeah.
The feedback piece is actually very critical, because not only does it need to be specific, it needs to be goal-oriented. So the feedback, it's not praise, it's like, oh, you did a great job. It's like, you clearly communicated this thing, or you didn't clearly communicate this thing, or you made this mistake. There's some argument, I know that Stephen Klontz does this. He and I just had a whole discussion where the way his assessments are set up, as soon as a student submits, they can see a partial correct answer. So they're expected to start their revision process before he even gets to it. And half the time, because if they can see they didn't get the correct mathematical answer, they're supposed to start working on it. And a lot of times they've already revised it and submitted a revision before he ever gets around to grading it, which I think is really interesting. I definitely do a lot of things like, hey, you made a mistake in this spot, find it and fix everything. And that's my first set of feedback. So that kind of thing is very specific. There's also a quick question from Terry Christensen. The time commitment it took to develop the type of course, it depends whether you ask us about the first time we did it or how much time it is to now. So the first time I did it, I decided to dive off the deep end 2 weeks before the semester. And again, it was horrible and yet still worked and did much better than traditional grading. The statistics, the big statistics class that I do, we had a year to implement, but it wasn't just the mastery grading, it was a full course redesign of content and everything else. And I mean, we just never stopped tinkering as far as ongoing time. Every one of us, I think, has never stopped tinkering with our classes. So it can take anywhere from as little time as you want to probably a full semester of thinking and, thinking about it and figuring it out. One more, group projects, reflection papers, etc. One of the things I love to do with especially reflections is, in order for them to get credit towards my habits of mind standard with the homework, is they have to actually reflect. Even without revising, they have to put reflections in their homework about what was hard about this, what did I learn about this. So I incorporate it that way. Drew, I know you and I do the team-based. I incorporate group stuff into my habits of mind. Do you do it some other way?
I ended up just taking all of that stuff out of the grade calculation, right? I used to have like peer evaluations and all that stuff. And I was never really happy with how students were completing it or anything. And so I've shifted to just having them do kind of self-assessments and self-group assessments, but it doesn't go into the grade.
We have someone, Anne, who has had her hand up. So I don't know if that's still intentional, but Anne, I'm going to give you permission to talk. And thank you for having your hand up if you meant to have it.
It was a mistake, sorry.
No worries, no worries. Okay. And then there was one other one. Oh, Faith said, do any of you teach at schools that require percentages? I am not aware if I do, I don't think I do. one of the things that I've had to get comfortable with, and this is something I don't think I've mentioned yet, I'm adjunct. I'm an adjunct faculty member. I am at Cal State. We do have some contracts. I just got my first 3-year contract. But I have some situations in my personal life where if I were to lose this job, it wouldn't be the end of the world. So I decided to exercise my privilege. And I just went ahead and did this. And I'm like, if y'all hate it, fine, fire me. And I've been able to lead the way, which I feel very privileged to be able to do that. And my department has embraced it with a little bit of side eye, but I'm working on all my tenure lines, but I am definitely not coming from a position of power in my experience.
So Dan asked a good question. I think would be a good way to tie things up. Could we go backwards by one slide to the philosophy? Oh, sorry, that one. Yep. And I just wanted to put this up here as a reminder. We've gotten into lots of details. We've talked about many different possibilities. It can be overwhelming, but the philosophy is the core of this, and you can use this to drive what you want to do and what you don't want to do in your own classes. And that is that grades should reflect demonstrated mastery of course content, right? Students need to reach specific goals, and they should also encourage, right? Have a positive effect on learning. And this is critical. Everything else is details. There's a lot of details, but everything else comes from this philosophy to begin with. All right, with that, I think we are at our break right here. And we have a timeline coming up in a moment right here. So right now we have a coffee break, we're calling it, until 3 o'clock Eastern, so that's half an hour. And after that, at a new link, so check your Zoom links, is our big keynote of the day, Linda Nilsson, who will be speaking about specifications grading. And we will see you then.
Bye, everyone. Thank you. Stop the recording.